Nanotechnology, Assistant Professor, Department of Chemistry. First of all, I would like to welcome you all for today's webinar on recent advances in nanotechnology. In this today's world of materials, it has become very imperative for all of us to know more about the recent advances of nanomaterials. And I fully believe we are going to really make use of this session. With this, I would like to welcome Dr. Dinamani Madam, Associate Professor, Department of Chemistry, to deliver the welcome note on this occasion. Yes, ma'am.
Thank you, madam. Good evening, one and all. It's my pleasure to welcome you all to this webinar. First, I would like to welcome today's speaker, Dr. H.C. Anandmurthy, Associate Professor, Department of Applied Chemistry, Adama Science and Technology University, Ethiopia. Sir, we are very much pleased to have you this evening, and we would be delighted to hear from you, sir. Now I would like to welcome our beloved principal, Dr. B.G. Prasad, who is a constant source of inspiration and support in all our activities. I also extend a warm welcome to Dr. K.S. Anantaraju, Head of the Department, Chemistry, in his absence here due to some preoccupied work. I wish to welcome all my fellow colleagues for today's webinar. Last but not the least, I would like to extend a hearty welcome to our beloved students who are very cheerful in attending such webinars and they take active participation in such activities. So welcome you all. Webinars play an important role in keeping ourselves updated with the latest trends in the field of science and technology. Today, we are here for the webinar on recent advances in nanotechnology by Dr. H.C. Anandmurthy, who has profound contribution in the field of nanotechnology. I fully believe that the students will be immensely benefited from this webinar, and also it is important for them to write a reflection note on the webinar, which will be assessed towards their internal assessment. So with this, I request all the students to be very attentive during the session as it is important for their AAT activity, and they need to submit a report which will be evaluated for 10 marks and towards their internal assessment. So make a note of this, all the students. With this welcome note, I once again welcome one and all for the webinar.
Thank you, madam, for your welcome note. Now, I would like to welcome Dr. Surendra B.S., Assistant Professor, Department of Chemistry, to introduce the speaker to the audience.
Thank you, madam. Good evening to one and all. It's my pleasure to introduce today's speaker, Dr. H.C. Anandmurthy. Dr. H.C. Anandmurthy is currently working as Associate Professor, Department of Applied Chemistry, Adama Science and Technology University, Ethiopia. He is also serving as an adjunct professor at Savita University, India. He worked at various prestigious universities in India, Tanzania, and Ethiopia from the last 25 years. He has taught various chemistry courses to UG, PG, and PhD students for the universities. Professor Anandmurthy has published more than 180 reviewed paper in the international journal with H index 28, I-10 index 77, and also he has authored 10 books, 22 book chapters, 6 compendia, and also he has total of 5 patents to its in his credit. He has carried out several projects and guided 16 UG students, 7 PG students, and 3 PhD students. He is currently working on 3 projects. One of them was sanctioned recently by Telecom Malaysia for the project on the development of electrochromic smart windows. And he is a member of ISTE, IRI, ECSI, CSI, NESA India, CSE Ethiopia, ACS USA, and newly elected member of International Council on Materials Education, University of North Texas, USA. Dr. H.C. Anandmurthy has recently been elected as a Fellow, Royal Society of Chemistry, London, UK in the year 2022. He has been serving as a guest editor for the Journal of Nanomaterials, Evidence-Based Complementary and Alternative Medicines, frontiers in medicine, food and science and technology, results in chemistry and micro machines journals. Along with he has received a best paper presentation, certificate of excellence for committee surveys, and a certificate of excellence by Elsewhere Researcher Academy. He has recently received excellent research award at Asia Science, Technology and Research Awards Congress held at Tiruchi, Tamil Nadu, India in 2023. With this brief introduction, I would like to introduce. I would like to welcome our Dr. H. Anand Murthy to address our students. Thank you, sir.
Sir, can you share the PPT, sir?
Yeah, let me. Can you see the full screen now?
Yeah, full screen. Yes, sir. Now we can see, sir.
Yes, sir. Visible.
Okay. First of all, let me thank the management of the University, Dhananand Sagar College, for providing me this opportunity. And I also thank the head of the department, Dr. Anant Raju, and the colleagues, Dr. Dinamani and Dr. Hemavati, Dr. Surendra, for this brief introduction, as well as the initial starting of this program. Thank you one and all for giving me this opportunity. Let me start the topic, the recent trends in nanotechnology. Maybe I think the students will not get back to me. They can only hear.
Yeah, they will have their questions in the chat box. They
Chat
can
box.
post their questions, sir. Yes, sir.
Okay. So am I audible now? This voice
Yes,
is
yes.
okay?
Yes, sir.
Yes,
Sure.
sir.
Okay. So we'll just proceed.
Yes, sir.
So the content of my talk includes introduction to nanotechnology, applications of nanotechnology, that includes applications in advanced engineering materials, energy materials and storage materials, nanomedicine, drug delivery, electrochemical sensing and biosensing, imaging and sensor materials, catalysts, foods, personal care products, advanced aerospace, defense materials, sporting goods, etc. So there are multi dimensional applications, and also at the last now we'll also have the future of this nanotechnology. So the students must aware of the fact that today we are living in the world of nanomaterials. So there has been a time where people were all the time working on creating the novel materials, but these days the materials world has been transformed into nanomaterials world. So most of the researchers in the world, they are presently working on only nanomaterials. So nanomaterials transform the science and engineering into nanoscience and nano engineering and nanotechnology. So today, the students must aware of the fact that we are living in the world of nanomaterials, nanoscience, and nanotechnology. So we are going to discuss most of the applications part. And before that, let us just have introduction about this nanomaterials. So it dates back to 1959, when Richard Feynman of the California Institute of Technology gave what is considered to be the first lecture on technology and engineering at the atomic scale. So he said a very important statement that there is a plenty of room at the bottom at an American Chemical Physical Society meeting at Caltech. So this is actually one of the revolutionary thought introduced by Richard Feynman, the great physicist, in the year 1959. So he actually won the Nobel Prize in Physics in 1959. So what he said is that what I want to talk about is the problem of manipulating and controlling things on a small scale. So if you can manipulate, materials at the nanoscale, you can see there will be tremendous, modification in the properties of the materials. So you can see the comparison of the size of the Earth with size of a nanoparticle having 50 nanometer size. So I have a saucer ball with 22 centimeters. So there is a huge difference in their sizes. So when you move from bulk to nano, you will see the tremendous transformation in the properties of the materials. That's what we are going to see that. See, you can see in the normal world, we have water molecule. You can see the dimension is very, very small. And next to that, we have nano devices, nanopores, dendrimers, nanotubes, quantum dots, nanoshells. All these are coming under nanomaterials. Next is white blood cell, then a period in tennis ball. You can see there is a small variation. So nano means, as you know, 10 power minus 9, it refers. So nanomaterials. So all those materials with this dimension of nanometer, basically we consider 1 to 100 nanometer as the nano world. So any material with that particle size or that size ranging between 1 to 100 nanometer will come under this category, nano. So these applications of this nano materials extended into a lot of sectors. So the potential impacts of nanotechnology includes novel material synthesis, and also in the technology, healthcare, and environment. So today, almost all the sectors have been utilizing the advanced nanomaterials and applications of nanoscience and technology. So it covers, a lot of, sectors, and you can see that, it has entered from our day-to-day life, domestic applications to industrial application, technical application, medicinal applications, and environmental applications, and many sectors. So this is actually the greatest advancement in the field of nanoscience and technology. And you may be surprised to see the kind of materials that people are synthesizing nowadays with their research knowledge and the implication of their ideas. So what is this nanotechnology? It is the manipulation of matter at the near atomic and molecular nanoscale level through engineering and scientific design. So nanotechnology is essential in the production of new materials, structures, systems, and devices, and seeks to improve functions and reactions of products. Today, we have been synthesizing the material in the nano form. So earlier, there was a period, maybe 25 to 30 years before, we were just making the bulk materials. But if you visit any of the laboratories in the recent days, you will always find only nanomaterials. The reason is that the nano scale will define, certain set of properties and add novel, characteristic to the materials. So those characteristics will definitely be beneficial for our work. So nanotechnology has a potential in variety of industrial applications, such as advanced engineering materials, nanomedicine, drug and gene delivery. So just to mention few, there are many such, applications which we are going to discuss in the session now. See, nanoparticle is also used in the cancer treatment. You can see imaging and sensors, energy generation, and storage applications. See, nanoparticles, of course, they have been very active, and they can be introduced into any part of the human body, so that the treatment can be executed at that particular point where there are affected cells. So this is how nanoparticle is also used in the treatment of cancer. Not only cancer, there are many diseases which can be cured by using this nanotechnology nowadays. In addition, the energy generation and storage of materials can also be done using these nanomaterials. And at the same time, they can also be used as catalysts, foods, and personal care products in the present day. So you can just see the nanomaterials typically measure between 1 nanometer and 1000 nanometer. Basically, we consider the range, especially in the nanomaterials, 1 to 100 nanometers dimension as the nano world. Less than 10, let's say 1 to 10 nanometer will be taken as a quantum world. So quantum dots come in the range 1 to 10 nanometer. And all those materials or particles are any form of any nanoform for that matter. We have nanotubes, nanostars, nanoflowers, nanocubes, nanowires. All these come under the size range between 1 to 100 nanometers. So they're all nanomaterials. So you can see plenty of these materials coming in this range. At the same time, the biological materials like genes, ribosomes, and antibody, and even viruses, DNA, the size comparison is given here. So basically, as for your, just for your information, the nanomaterials are those materials whose size range lies between 1 nanometer to 1000 nanometer. And specifically, we move most of the time between 1 nanometer to 100 nanometer. Now you may ask, what is this nano? Why does nanoscale materials are performing better than the bulk material? A very important thing is that as the size at this size, materials begin to exhibit unique properties that affect physical, chemical, and biological behavior. So you can see in this simple diagram, it's very important for you to understand why material, when transformed from bulk to nanoscale, exhibits such an extraordinary property, exhibits extraordinary activity. It's because of the surface area. You can see the cube 1 centimeter cubical particle. The total surface area of that particle is just 6 centimeters square. If you break down that single particle into cubes with 1 mm size, you can see the total surface area becomes 60 centimeters square, 6 to 60 centimeter. If the same particle is broken down into 1 nanometer cubes, total surface area becomes 60 million centimeters square. See the difference. The same material in the bulk has 6 centimeters square surface area, but in the nano form, it has 60 million centimeters square area. So this is actually basically the difference between the bulk material and nano material. So not only the surface area, when you're taking a material from bulk form to the nano form, you can see the property change with respect to mechanical aspects, electrical aspects, optical aspects, and even thermal aspects, etc. Even the structural aspect, the physical structure also gets affected when the material move from the nano form to the bulk form to nano form. So this is what is very important for your understanding. So on moving from the bulk scale to nanoscale, large number of property variations happens, and we are utilizing those properties for our benefits, for our applications. So types of nanoparticles can be categorized in of course many major divisions. So one, you can see carbon based one. We have a diamond, one of the allotropic forms, then fullerene. Fullerene is a football type of material where carbon is an sp2 hybridized form, and the same graphene sheet present in a graphite can be rolled down to make a carbon nanotube, and then graphite, and we also have a graphene oxide, and then carbon dioxide. So these are all varieties of nanomaterials. Today, you must know that most of the researchers in the field of science and engineering are working only on nanomaterials, not bulk materials. So bulk materials find very less, usage or applications compared to nanomaterials. So most of them are doing the work on this particular aspect. So in addition, the metal-based nanoparticles are being synthesized in the laboratory by various chemical, physical, mechanical, and biological methods. And among all of them, few methods are very popular, and most of the researchers in India and abroad, they are utilizing those methods like salt gel methods, microemulsion methods, and green nano methods, etc., for the synthesis of these metal nanoparticles or metal oxide nanoparticle. You can see these metal nanocrystals, they have been used in high density magnetic storage materials, then next generation non-volatile memory materials, next generation hydrogen storage materials, drug delivery systems and medical materials, and also display materials. So every case, you can see the utilization of nano form of the material. And in addition, we also have a special category of chemical molecule called dendrimer, a synthetic polymer with a branching tree-like structure. It appears like almost like a tree. So this can be of course, synthesized by two different methods. One is called divergent method, the other one is called convergent method. And this also plays significant role in drug delivery system. So where this dendrimer is packed with that drug and introduced into the system, and changing the temperature or pH of the medium, the structure will change, and the components which are present in the dendrimer will be released into the body. So this is another application. Now, most of our researchers in the field of chemistry and chemical engineering were just, busy making nano composites out of these materials. See, nano composite is, that there are plenty of examples for natural composites as well as synthetic composite. Wood is one kind of composite, and there are polymeric materials which are composite. Your bone is a composite material, so they are natural composite. But now man has synthesized hundreds of synthetic composites. But you should know the definition that a composite is made of two or more materials. Basically, one material is reinforced into another material. So the material which is reinforced into the system is said to be reinforcement, and the one which gets reinforced by this particle is said to be the matrix. So we have one particle as a reinforcement, and matrix is another substance. So you are introducing one through the other. So this is what is happening here. You can see example. So we're using nanopowders to get a nano composite. So in this case, we have composite copper oxide and aluminum. So they are making energetic nano composite. In this way, in chemistry, we have tried many number of nano composites for varieties of application. Today, as I already told you, the nanomaterials basically includes various nanoforms of materials, at the same time nano composite forms. And these composites are again supported on certain supports like graphite carbon nitride or carbon nanotube or graphite or reduced graphene oxide, etc., to increase or enhance their properties. So one of the important properties that the chemists are looking includes the photocatalytic activity. Most of the metal oxides, they are photocatalytic in their behavior. That means they act as a catalyst in the presence of light to bring about certain kind of reaction. Especially if you consider a pollutant, basically the pollutant that comes out of the industries, they are very harmful to our environment. So we need to degrade them. So the simple phenomenon of degradation is either catalysis or photocatalysis. So in the presence of visible light, we can easily, degrade that harmful pollutant into carbon dioxide and water. So that is one of the methods. So in the case of photocatalysis, we use this catalyst in the presence of light, either visible light or UV light, to degrade the material. So simple examples include zinc oxide and titanium oxide. So some nanoparticles of photocatalytic properties that scientists can engineer to speed up reactions using a light source. So photocatalytic nanoparticles are organic, so may have antibacterial properties and are considered cost effective. And you also must know a simple mechanism how degradation happens. See, the photocatalytic nanoparticle titanium dioxide, that every metal oxide as a semiconductor exhibit the band structure. It has a band structure, valence band and conduction band. You can see the energy gap between the two bands is Eg. That is Eg. You can see Vb and Cv between the two. So when light falls on this kind of material like titanium dioxide, the electrons are allowed to jump into the conduction band. So they move from valence band to the conduction band. So when electron move to conduction band, an additional electron is generated in the conduction band. At the same time, a positively charged hole is created in the valence band. So now, if we can utilize these electrons and holes to generate reactive oxygen species, so those reactive oxygen species are able to degrade the pollutant molecule. See, the pollutant molecule can be degraded to water and carbon dioxide. So this is actually a significant phenomenon. So the photocatalysis, the meaning is that there is a catalytic phenomenon that is initiated by the light, visible light. Sometimes, depending on band gap, it can also be ultraviolet light. So photocatalytic nanoparticle, though this process nanoparticle such as titanium dioxide acts as organic destroyers and degrade organic toxins in the presence of hydroxylation. So a chemical process that introduces a oxygen bonded to a hydrogen or a hydroxyl group into an organic compound. So these are actually basically called a reactive oxygen species responsible for the degradation of the pollutant materials. So we have already understood in the mechanism that the titanium dioxide acts as a photocatalyst and degrade the organic compounds into water and carbon dioxide. So this titanium dioxide serves as a the purpose of the photocatalyst. So when visible light falls on the system, electron hole pairs are created, and these electron hole pairs are responsible for the oxidation and reduction of the atmospheric oxygen, forming the reactive oxygen species, and these reactive oxygen species degrade the pollutant organic compounds into neutralized compounds like water and carbon dioxide. So in addition, the other uses of nanoparticles are also there. So there are essential industries such as in water sanitation and purification. They're also used in products from antimicrobial agents, cosmetics, sunscreens to semiconductor system. So there are plenty of applications happening in this particular field. So when it comes to materials, to mention few, you can see nano-coated fibers are being used, water and stain resistant, antibacterial materials are there, the fabrics are there, guitar strings feels like non-coated, so coated to improve strength, sunscreen, most of the people uses the sunscreen lotions for the production from UV rays, then also water resistant and transparent. And in addition, you can see the sporting goods, basically they're all composite in their synthesis, nanocomposites, lighter and stronger carbon composites, silicon dioxide, nanoparticles. So most of these materials strengthen composite structure to provide improved handle designs with optimized flex responsiveness and more kick. And when it comes to electronics, we have seen many such small electronic items, gadgets, computing hardware, processors 22 nanometer, flash memory 19 nanometer, organic LED displays very lighter and thinner, more energy efficient, cheaper to manufacture. And even in energy storage and solar cells, there has been tremendous improvement in the storage capacities. So there are a lot of improvement in all the sectors by the application of these materials. So when it comes to solar cells, you can see plenty of designs and plenty of structures. The first one, silicon single crystal, silicon polycrystalline, then thin film, organic, the dye-sensitized, then the bulk heterojunction. These are all various varieties of materials used for making the solar cells. Next, in medicine, there is a very important sector that is a targeted and traceable drug delivery. You can introduce the drug of your choice into any part of the body. And it is also used in enhanced imaging and sensitive detection. So this not just limited to only the drug delivery. So these nanotechnology is also playing significant role in even the, what you can say, the characterization or even getting information about where exactly what is happening in the body, even in the analysis, it is playing a significant role. And nanofibers create fusion of air around fabrics. So you see 10 nanometer carbon viscous bond with cotton, acts like which was many liquids roll off. You can see nano bands that refuse to stain, liquids bead up and roll off. So these kinds of fabrics are being manufactured in industries. Any stain that falls on it, without leaving behind any stain, immediately will get out of the system. So nanocare fabrics with water, cranberry juice, vegetable oil, mustard oil, paper towel.
When we are doing maybe some temperature or something, when students are doing, then it won't come. That is what people we won't give to exams and
Sir, 1 second.
So protective nanopaint for cars, water and dirt repellent, resistant to chipping and scratches. brighter colors enhance the gloss. In the future, could change color and
Part of some itself calculated amount we added. The code also will tell you.
So nano paint on buildings could reduce pollution when exposed to ultraviolet light. Titanium dioxide nanoparticles in paint break down organic, inorganic pollutant that wash off in the air. You can see just now we have discussed that the titanium dioxide acts as a photocatalyst. So when you use this in paint, it breaks down organic and inorganic pollutant that normally washed off during the rain. So decompose air pollution particles like formaldehyde. And also when it comes to the CD and DVD, you know, the storage scale in micrometers changes to nanometer. You can see simplest examples from moving from CD to DVD to silicon plate to a nano, storage. The dimension change, is going to be almost 1 million times greater storage density in total. So when you are moving from the bulk to nano, you will always see enhanced performance and enhanced properties and enhanced characteristics. That is what is making the researchers to move into the nano world significantly. There are so many techniques which, which is basically not understood by our modern day researchers. Most of the advanced countries are using this kind of techniques, nanolithography, to create a tiny patterns that they lay down in atom by atom. You can see the system here from the tip of the atomic force microscope. Molecules can be arranged onto a substrate at the nano level. So this is the transporting of molecules to a surface by tip in nanolithography. So you can see a picture of Mona Lisa 8 micron small created by FM nanolithography. So these are all techniques. Next, the neuroelectronic network interface nerve cells with semiconductors. So this is again related to medicine. Possible applications in brain research, neurocomputation, prosthetics, and biosensors. So snail neurons grow on a chip that records the neuron's activity. So this is basically connected with nanotechnology in relation to medicinal applications. Next, quantum dots glow in UV light. So injected in mice collecting tumors and could locate as well as 10 to 100 cancer cells. So you can, this is another important application where you can detect the, the problem in the body by using this quantum dots. So nanometer sized crystals that contain free electrons and emit photons when submitted to UV light. You can see in these mice the colored objects that indicates the accumulation of the nanoparticles in that particular area where there is a diseased cells. So in that way, the nanomaterials also find applications in the identification of the disease. So quantum dots, as I already told you, they are lower in dimension compared to the nanomaterials. Basically, few nanometer. So normally from 1 to 10 nanometer material range is taken into consideration to be a quantum dot. Next, we have many composite materials. Most of the vehicles or even the boats, they are using this ROXDM nanotube reinforced carbon fiber refrag. So these are all materials. Even a lot of materials in our automobiles have been replaced with a nano composite material. Earlier, people were using a lot of alloys and metals, but in that place now we have carbon-based reinforced materials. Next includes the silica or TiO2 coatings, undetectable by taste, smell, increase the shelf life. Then the fat cluster, that acts as fat but lowers amount, and also in packaging industry, these nanomaterials are being used. Plastic bottles embedded with nanoclay too. So, in addition, nanotechnology in national defense. What can nanotechnology do for the military? See, in the military, these nanomaterials are finding enhanced applications. Example, clothing with a greater tolerance for temperature changes. You know that the soldiers or army or navy people, they work in extreme conditions, so they need different kind of clothing. So for that, you can use these material. Increased surveillance for better protection, smaller cameras, cheap, small, and more effective weapons, exploration of the oceans, augmenting human performance, scratch resistant surfaces, stronger, thinner, and cheaper glass, change shape of objects, that is armor like fabric, coatings that don't degrade, and invisibility, faster, intensive medical help, lighter, faster aircraft which use less fuel, so submarines and planes that can go undetected by radar. So there are plenty of applications in the field of national defense. So let us just look at a few of them. You can see here a soldier wearing a specific jacket where you can see through the jacket and can see the person behind him. How could you become invisible? There are a couple of nano ways. So scientists are manipulating light so soldiers seem to disappear. So scientists are also working on electrochromic camouflage, where fabric which changes colors instantly to blend in with the surroundings. And also design of nano lens that involves a tapered stacked arrangement of silver nanorods. The layers are separated by nano gaps, which prevents the propagation of plasmons, resulting in extremely low loss of energy and thus making long distance imaging possible. So it appears that a gap size of 10 nanometer gives the optimum value for efficient imaging. Armor as strong as a snail. So sea snails and abalone are guiding scientists in their search for strong and lightweight armor. Other besides the military will benefit from these new nanoscience developments. Firefighters, police officers, and other emergency responders, they are using these kind of materials. That includes this nano armor for creating super strong materials that uses tungsten, not carbon, for the basic material. It's 5 times stronger than steel and at least twice as strong as any impact resistant material currently in use as protective gear. It has withstood the equivalent of dropping 4 diesel locomotives onto an area the size of the fingernail. So possible application for these new nano materials are ballistic protection, personal body armor, bulletproof vests, vehicle armor, shields, helmets, and protective enclosures. So this is one of the examples of bulletproof jacket made by Indian scientists. A new nano armor is called smart body armor. It weaves thin pads or cloth from fibers that can sense the impact of a bullet or shrapnel and automatically stiffen. So this material would be even more resistant to penetration and less cumbersome than the ceramic plate armor to wear. So concerns about biochemical warfare have resulted in exploration into nano-size umbrellas that open to seal the cloth spores, making it impervious to airborne chemicals and pathogens. So it's easier and lighter than the current equipment required. So these are all the new nano technology materials. So nanomedic sensors would provide the soldiers a vital sign and location to medics via radio until the new nano sensored garment is ready. Soldiers will wear an adhesive chest pad fitted with sensors and a tiny radio. So if a soldier is injured in the arm or leg, thanks to nanofibers in the uniform, the fabric would constrict into a tonic wet. So it will not allow the blood to move into the body. So this will be a real life saver because half of all battlefield deaths are due to massive blood loss before wounded soldiers can be treated. And in addition, nanotechnology can also be utilized in artificial muscle making. These days, the youngsters are going to the gym to stay fit, at the same time build muscles. So artificial muscles that could enable soldiers to leap tall walls, if not buildings, are in the works too. So one type uses nanotechnology and electricity to make these artificial metals. So it flexes when jolted by electricity, then relaxes when the electricity is turned on. So far, though, its reactions are much too slow. And also in security, big fighter jets are. So yesterday, the next generation of fighter jets are nano-sized jets, the size of a seed that can pretty much go anywhere. Scientists are working on this revolutionary remote control nano air vehicle. They will be able to collect military intelligence both indoors and outdoors. One weighs no more than 10 grams and carry a payload of up to 2 grams. So they will help protect the lives and enhance the operational effectiveness of soldiers and first responders. So finally, when it comes to the summary, science at the nanoscale. That's what we said. As far as the present day research is concerned, a lot of researchers have been, focusing their work towards nano invention, nano discovery. So an emerging interdisciplinary science is this nanoscience and technology, which integrates chemistry, physics, biology, material science, engineering, earth science, and computer science, and even medicine. So the power to collect data and manipulate particles at such a tiny scale will lead to new areas of research and technology design, better understanding of matter and interactions, new ways to tackle important problems in healthcare, energy, environment, and technology. A few practical applications now, most are years or decades away. So when you are moving from the bulk world to the nano world, definitely there are great challenges when it comes to environment pollution. Even these nanomaterials, after their usage, they are going to pose a lot of threat to the society as a whole because of their higher levels of reactivity, as you know. So these nanomaterials are applied in various sectors that, as I already mentioned, including the agriculture or automobiles or cosmetics or energy sectors or in the field of computer science. So every sector, these materials have been finding a new role. So as a result, a lot of investment has to be done to the field of nanoscience and technology. So I hope that you have understood the significance of these nanomaterials and nanoscience, nanoengineering, and nanotechnology. So this is going to be there's going to be significant contribution coming up from the side of material scientists in the near future. Definitely, I hope that these new nanomaterials, nanoscience, and engineering will definitely transform our world into a better place in the near future. So with this, I end my lecture and I welcome any questions from the student side. Thank you very much for giving me this opportunity to interact with you.
Open madam. Madam.
Okay. Students can ask questions if you have any questions. Now question is session.
Sir, here one question is there, sir, from our student.
Yes, sir.
Sir, please tell me the differences between the nanomaterials and nanocomposites and suggest its some applications.
The nanomaterials and nanocomposite is also one of the form of nanomaterials. So in nanomaterials, any material that has a nano dimension between 1 to 100 nanometer will be considered. So nanocomposite is one of the form. So you can also have nanoparticle or nanotubes, nanowires, nanorods. So when you are combining one form of material into another matrix, you get a nanocomposite. That's the thing. And applications in all lot of fields are there, as we already discussed, like photocatalytic application, sensor application, medicinal applications. The materials are being used in energy sectors, environment cleaning, and so many applications are there.
Yes, sir.
Thank you, sir. That was really a wonderful talk. One more question is there from the students regarding the synthesis. The students wants to know what are
Uh-huh.
the different types of synthesis and which is the best type of synthesis for nanomaterials, sir.
Yeah, recently, there are three different methods by which we synthesize material: physical methods, chemical methods, and biological methods. So it depends on the kind of materials that you are going to synthesize. So most of the time, we are going by chemical methods compared to physical methods, because the physical methods involve a lot of
ಇನ್ನೊಂದಾಗಿದೆ
energy and
ಇನ್ನೊಂದು ಗ್ರೂಪ್
instrumentation. So, and in biological methods, you can consider the nano, that is a green nano method, where we are using plant extracts and bacteria to synthesize nanomaterials without even using any toxic chemicals. So there are plenty of chemical methods as well as green methods being applied by researchers to synthesize nanomaterials.
Thank you, sir. Thanks a lot. Thanks a lot, sir, for your insightful advice. And now I would like to ask Dr. Dinamani Madam to give a vote of thanks.
Okay, thank you, madam. So actually, there are many questions which we will discuss
Okay, madam.
later, sir, because as we have come to the end of the session, we will discuss
Okay.
later. Now,
Okay.
if there are no more questions, let us thank today's speaker, Dr. H.C. Anand Murthy. Formally, I would like to express my deep sense of gratitude to today's speaker, Dr. H.C. Anand Murthy, for having accepted our invitation and also for having accepted our request to deliver a talk on such a wonderful talk within a short notice of time. Sir, thank you very much. And I am sure that our students are richly benefited by your informative talk, sir. And one more thing, sir, we
Welcome,
will be
madam.
looking forward for such wonderful webinars in future also. So be associated
Definitely.
with our department, sir, for the exchange of knowledge. We will be always contacting you in future also, sir. Thank you, sir.
Definitely, madam. Definitely, I will
Next,
do my level best to have a collaboration.
yes, sir. Actually, we are also actively involved in this nanomaterial research. So our students,
Okay.
we are guiding some projects for final year students and all. And also in our department,
Okay.
many are concentrating on research in nanotechnology. So definitely your
Okay.
help and encouragement from your side is required for our colleagues and also as well as students, sir. Thank you,
Definitely,
sir.
madam. We
Thank you,
will
sir.
go
Thank you very
together.
much, sir.
Sir, thank you very much, sir.
Surendra.
Thank you, sir.
Yes, sir.
Okay, thank you, Surendra.
Yes,
Sigana.
sir. Thank you very much, sir, for your accepting our invitation. Thank you very much, sir.
Okay.
Now, I request all the students to take a snapshot and whatever snapshot you have taken, please, so you have to get the printout. This will be helpful for your EAT. Thank you. You can all log out.
Yeah, and one more thing, I just wanted to thank all my fellow colleagues for their wonderful cooperation in conducting this webinar successfully. And also, I want to thank Mr. Mohammed Imtiaz for providing us with the Zoom link as well as the technical support provided. Thank you, sir. And at the end, I would like to thank our cheerful students, which are who are so enthusiastic in attending webinars and invited talks. So thank you. I thank one and all for the support given and also for making this event a grand success. Thank you. Thank you one and all once again.
Okay, madam. Thank you. Bye.
Thank you,
Thank
sir.
you,
Thank you,
sir.
sir. Bye, sir.
Bye, sir.
Yes. Bye, sir. Okay,
Sir,
sir.
Imtiaz sir,
ಯಾರು ಹೇಳಿ? ಮೊಹಮ್ಮದ್ ಸರ್.
Muhammad sir, ಸರ್ ಅವರಿರಲ್ಲ ಅನ್ಸುತ್ತೆ. ಓಕೆ.